Good morning, welcome, and good evening to some. Thanks for joining us. Today we're going to talk about dashboards and data visualization using Xamarin and ShinobiControls. Today your presenters are Colin Eberhard, Sam Davies, and Mike Bluestein. We also have Stuart Gray that will be answering questions. So please use the questions box, and this will be recorded, so you can watch it, at your leisure sometime later today. It should be posted. I'm going to turn the time over to Colin, and let's get started.
Yeah, thanks for that introduction. So as Rich pointed out, we're talking today about dashboards and data visualization using Xamarin and ShinobiControls. A little bit more about some of the presenters. I'm Colin Eberhard. In the top left, I'm CTO of ShinobiControls. Right beside me is Sam Davies, who you can see in the bottom left here. Sam's our technical evangelist. Bottom right. He's our technical evangelist, blogger, presenter, speaker, and all kinds of cool things like that. Bottom left is Stuart Gray, who's sat behind a keyboard waiting for your questions. So as Rich mentioned, please ask away. And we've also got Mike, who's going to be talking a little bit later about the component store. So as a quick summary for you, this slide shows what we're going to talk about and for how long. Obviously, we decided that we'd go for a visualization rather than a boring bullet point list. So what we're going to talk about initially is why you should visualize data, why you should actually show it graphically rather than just in pure tabular form. Then we're going to talk a little bit about good data visualization. Following that, a brief introduction to ShinobiControls. We're going to tell you a little bit about who we are and what we do. And then we're going to get into the interesting bit, the code. I'm going to be passing over to Sam, who's going to do a quick start with Shinobi. He's going to show you how easy it is to go from a new project in Xamarin Studio, add Shinobi charts from the component store, and render something on screen. And he's going to do that in 5 minutes, and I'm going to get my stopwatch out and time him. Then following that, we're going to talk about a dashboard that the two of us have been working on. It's currently on GitHub, and we'll show you that in a little bit. We're basically going to talk about the code and have a bit of a play around, do some live changes to it. At the end, we're going to have a bit of a wrap-up, and we're probably going to answer some of your questions on air. So, why should you visualize data? I'm not going to give you a terrible fancy explanation for this. I'm just going to dive straight into an example. This is some data that I pulled out from a website. There's a little reference down the bottom if you want to find it for yourself. This data shows trends in Xamarin iOS jobs. There's a UK-based job site that publishes job statistics so you can see what's happening in the job market. And this is some data that I pulled from the site. So this tells you the percentage of job postings that are tagged with Xamarin iOS. So to me, this is pretty interesting data. But presented in this form, it's actually quite hard to read. All I can see at the moment is a sea of zeros, and the proportional width font makes it fairly hard to compare the numbers. So it's not terribly well presented. The first thing I'm going to do is just clean it up a bit, use a better font. I've multiplied everything by 100, so we have hundredths of a percent to remove that sea of zeros. Everything's got the same number of decimal places, so the decimal points line up. And to be honest, I think this is about as good as you can get with tabular data. So looking at this, just glancing at this data, all that really stands out to me is that May and June of this year were the biggest numbers. We've got a bit of a spike at the end. But if we show it in graphical form, you can immediately understand the data. It becomes much more clear. So we can see immediately here that 2011 to 2012, there were some fluctuations, but it was effectively steady. 2013, you can see those two big numbers at the side, but I think just as interesting is you can see where it's accelerated. You can see that acceleration started at the start of 2013. We've also got these funny little dotted lines, and what those show is breaks in the data. I can bet that no one spotted from the table that there were actually data points missing. So as the little annotation at the bottom says, you can see at a glance what's going on with this data. It's much clearer than the tabular form. So why visualize data? Really, it's just to make use of the fact that our brains can subconsciously spot patterns, visual patterns in data. So rather than having to use conscious thought, we can rely on our subconscious mind and our ability to spot patterns. That helps us to understand the data much more quickly. So now that we've understood that data visualization is a good thing, I want talk about how to make a good data visualization. How do you really make use of your brain's ability to spot patterns? And I'm not going to delve into the theory. There's a lot of theory behind this about how the mind works, and from understanding how the mind works, you can understand how to apply that to data visualizations. If you're really interested in this, I'd encourage you to take a look at this book by a chap called Stephen Few. If you're designing dashboards, this is kind of your go-to book. What I want to do instead is have a bit of fun and go through a work example. So this is a chart that I pulled out, a visualization I pulled out from a UK newspaper. And if you haven't guessed by now from my accent, we're actually a UK-based company, so that's why I'm picking out UK data that I care about. So, well, perhaps elections. So this is some data relating to elections in the UK. So they do polls where they ask people, which party you're going to vote for, and they show these pretty visualizations so that you can understand the data. And this is a terrible visualization. You look at that chart, look at the two charts and try to understand what's going on, and it's virtually impossible. Now, if you're listening to the recording of this webinar, I'd encourage you to pause the playback now, get a pen and paper out, and note down how many mistakes you can spot with these charts. See how many you can get. For the people listening live, I'm not going to pause for 5 minutes. I'm going to just spoil your fun and whip through some of the mistakes I've spotted. So the first one is the chart title. The title, Popularity by Generation, doesn't relate to the donut beneath it. It actually relates to the chart on the right, which is pretty confusing. The next one is the choice of color. We've got a kind of salmon-y color and a kind of hard to describe peachy color. It's actually quite hard to determine which data point belongs to which category. The next one is, I'm guessing the chart on the right is there to enable us to spot trends, to enable us to determine whether voters of a particular age tend to vote one way or the other. Without joining the dots, it's really hard to spot these trends. The next one, grid lines. This one is incredibly subtle. The grid lines are actually spaced at every 2 percentage points, whereas the labels are spaced every 5 percentage points. So every other grid line lines up with a label, which is just peculiar. The next one is the donut. As you can see, there's a lot of problems here. With the donut, which of those two slices is bigger? Personally, I can't tell. The next one, arbitrary graphics. We've got these grey lines here. It looks like they're trying to highlight them for some reason. And to be honest, I don't know why. The change. We've got a table as well to back up our data. Obviously, they ran out of ideas and just decided to slap a table in there. And again, I can't understand it because it's not visual. And finally, the units. The figures are in percent, but the units are sort of left in the bottom left-hand corner. They're nowhere near the numbers that they relate to. Again, it just leads to a very confusing chart. So let's have a go at fixing it. Let's try to improve it so we can actually understand the underlying data. So the first thing I'm going to do is tackle the right-hand chart. This is the popularity by generation. And here, as you can see on the right-hand side, I've connected up the data points so you can see the trends. And immediately you can see that there are trends. There's actually something interesting going on with the data. Also, I've been careful to include the 0% line. This is quite important because you can see the scale of the trends. We're not just looking at noise in the data here. We're actually looking at something important. Also, the colors. Each of the political parties in the UK has a color associated with them, and we're using the correct colors. This, again, means that people can make the association without conscious thought. Next up, the chart on the left. Replacing the donut with a column chart means that we can actually quite easily see which is the most popular party. And also visualizing the change here. We have the last week's popularity as a hatched version, and this week's as a filled column. And again, you can immediately see what the change is and understand the scale of it. Putting it all together, the final visualization. And again, we've added some artistic flourishes, some drop shadows and things so that it looks relatively visually appealing. But hopefully you'll agree that by fine-tuning the charts just a little bit, you can actually understand the underlying data. And that's it for a very brief whirlwind tour of data visualization and good data visualization. I really would encourage you to read around this subject. Just a little bit of knowledge will go a long way in this field. What I'm going to do next is give you a quick introduction to ShinobiControls, and that's because the marketing guys told me to. So ShinobiControls, we are an iOS component vendor, and we have a number of different products at the moment. Shinobi Charts is probably our most well-known. It's GPU accelerated, so it means that the charts are rendered very rapidly. You can render thousands and indeed hundreds of thousands of data points at 60 frames per second. It's highly interactive. You can pinch, zoom, you can throw the data around, and it's all super slick and fast. We also have grids, which support selection, sorting, grouping, all these sort of common use cases out of the box. We also have Shinobi Essentials, which is a collection of various other UI controls. We've got things like a tab control, an accordion, and quite a cool carousel control, which one of our team was able to modify to mimic the iOS 7 Safari tab switcher interface, which is really quite cool. We've got a few other controls as well. But one other thing is our controls are very Xamarin friendly. And what I mean by that is for all of the controls, we publish full bindings for C# to use within Xamarin Studio. Not only that, we convert all our API documentation as well. So we don't just do the bindings, you've got the full documentation. We also have a quick start guide, and most of our samples are ported across to Xamarin iOS as well. If you want to find out more about our controls, I'd definitely recommend going and having a look at the website. We've got blogs, product tours, and also a page that I really like is our showcase, where we just show what some of our clients are doing with our charts controls. And one of my favorite, again in the context of data visualization, is Server Density. They're a company who provide tools for remote monitoring and collection of data from servers. And as you can imagine, there's large quantities of data involved. So using our charts, they're able to render multiple series on multiple charts, thousands of data points, and allow people to understand the story behind the data. Just a few other little things. We've just released Shinobi Lab. I think that went live on Friday, so just a few days ago. What we're going to be doing in the future is throwing out a few ideas, basically, a few proof of concept ideas. And one of them is Shinobi Gauges, and we'll be adding some new things in the future. We're going to be playing around, trying a few things there. It's available to download now, and I'll be demoing it later on. Finally, Shinobi Charts for Android. We put out a beta a little while back, a few months back. We've been working hard. We've had lots of feedback. People say, yes, they definitely want the Shinobi chart for Android. And the good news is that we've talked to the developers this morning, and they're talking about weeks now rather than months, which is really cool. And another great thing is the Shinobi chart for Android will share the same underlying GPU accelerated rendering code. So you'll get the speed, but you'll also get the familiar look and feel with Android. And that's it for the sort of product pitch side of things. What I'm going to do now is pass you over to Sam, who's going to do a bit of live coding. What Sam's going to do, hopefully successfully, is demonstrate how to render a Shinobi chart straight out of the component store. So over to you, Sam.
Cool. Thank you very much, Colin. So if I fire up Xamarin Studio, as Colin said, I'm going to demonstrate how easy it is to get going with Shinobi using the component store. So I've literally just opened the studio. I've got nothing else going on here. I find the mouse. So I'm going to make grab a new solution. And we'll grab an iOS one, as Colin said at the moment. iOS only will have a single view application. Very, very, the simplest of all of the ones that we can put together. And what I'm going to do is demonstrate how to plot a parabola. Now, hopefully, I've chosen parabola, but I can't type it, so bear with me as we go through this. Parabola is just an x-squared graph, right? Just showing off with the web names. So if I just create that, then it will make a very standard Xamarin iOS application, same things that you'd normally expect to see. And what we're going to do, what I'm going to do is let's jump into the ViewController straight away. I'm just going to tidy it up with things that I don't need for this demo, so we don't need the memory control, and I'm going to throw away that and put in and force it to be landscape, entirely personal preference. So that's entirely standard iOS thing. Now, as we've talked about the component store, I'll show you quite how easy it is. You've got this little components thing over here on the left, and if you can grab that up and edit it in this menu here, then these are a list of the ones that I've installed before, so they're already on my machine, but I'll just quickly show you how easy it is to grab it from the store itself. there's this get more components thing up in the top right, and it will fire up the component library. And if I search for Shinobi, then you'll see the components that we have available in the store at the moment. So we've got the grids, charts, and essentials. So at the moment, I'm going to show you a chart. So if I click on that and bear with it, it'll fire it up. So as we've got all of the different things here, and here, because I'm just working on a trial, I would hit try. Actually, you can buy it as well. But since I've already downloaded it, rather than you watching while I download it, I'll just add that to the project. And as you can see, we've now got a reference to it in the component, and then the DLL has automatically gone in. Now, for those of you who have done any iOS stuff, then that's a hell of a lot easier than the Xcode way of doing it, so we're winning. Right, so I'm going to run through the stuff that you have to put together in order to any app that's going to have a Shinobi chart in it. All starts in a very similar way. We need to actually create the chart itself. So here I've created a chart, and if we do pull the import in, then we've just got a chart, and then this is kind of mirrors the iOS in it with frame type thing we've got here. So you'll see it all over the place in MonoTouch. We're creating it, and we're going to fill the ViewController or the view size that we've got, and we've got a couple of other things in the constructor here where we pass in axes types, one for x-axis, one for y-axis. There are all kinds of different axes that you can use. Here we're just using numbers because I want to show a mathsy type thing, but we've got a discontinuous axis, datetime axis, category axis, everything you would expect from a chart. And then also here I'm just firing in to make sure that it resizes as the screen resizes. Again, standard iOS stuff. Now, because I'm using the demo, then I need to put in a license key. That's just a property on the chart, and if I show you, if I can drag this across and show you, that's for later. Here we go. So in order to grab your license key, when you download the trial, then it'll automatically generate you a license key and stick it in the component store on Xamarin. So if you pop onto the component store on the web, then you can see the things that I've used before, the trial here, and then I've just copied that and pasted it in as a string. Very simple. Right, so we've got a chart, and what we need to do, all of the charts work in a very similar way to like UI table view, where you provide a data source, which is just an object which the chart will query and ask for data points and series and all that kind of thing. And then that will just provide it back and the chart will know how to plot it. So what we're going to do is create a data source. So this is going to be, excusing my typing, so we want to create a class. I'm going to call it parabola because I can spell. Call it a data source. And there's an abstract class that we want to inherit from called schart data source, like so, which has 4 abstract methods on it that we're going to look at later on. But first of all, we've just created the class, and let's implement the constructor for that. And I'll run through roughly what we've got going on here. So we've got a member variable here, which is going to be a list of all of the data points of type schart data point, which I shall describe in a bit more detail in a second. So we're in the constructor, we create the list for it, and then we loop through this kind of arbitrary range of numbers, creating data points. These schart data points have various properties on them. 2 that we're interested in here are x value and y value. Now, because I've said that we can have lots of different axis types, and these can obviously take lots of different types. Here we're only interested in numbers, so we're pasting the x value in as I, and then we're going to do I squared for the y value. Very, very simple. That creates the object we need, and then we just stick that in our backing store for those things. So then, when we construct one of these objects, we've got all of the data points that we need to plot on our chart. Now, I mentioned that this was an abstract class with abstract methods, and if we get Xamarin Studio to create those for us, then we've got 4 methods, and these are all you ever need to implement on the data source. This bit up here, I should mention, this constructor, is the kind of thing that I'm not going to go into great detail because that's where you would plug your data in. You'd come up with a way, and I'll show you later on an alternative way of doing this. But this is stuff that you've got the data you want to plot. This is how you plot it with these 4 methods down here. So the first one we're going to look at is the number of series. Now, the same data source can manage lots of different series. That is, on a chart, you could have 4 different lines. So the thing that Colin showed before, we had 3 different political parties. They would be 3 different series, and each series would have its different properties, colour and various other bits and pieces. They needn't all be the same type. And then we've got this get series. So this here defines what do we want the series to actually. Wait a minute. Let me type it, and then I'll explain what I'm talking about. We want a line series here because we're going to do it as a line. So this tells the chart how we want to plot these data points. So here we're going for a line series. You could alternatively go for like a scatter series, or you could column or bar chart or band series. But, loads of different things. So that there's determining what it is that we're plotting. Now, in this method here, we've also got this data series index. So that's if we've got this data source is managing more than one series, then here we'd know, well, actually, the first series we need is a line series, then we need a scatter series. So that's the way since we're doing a very simple example, we don't need to worry about that today. Get the number of data points. Now we've created our data points. So all we need to do is return how many that we've got in our list. And then finally, this last one here is get the data point, which again, using the same argument, we've created it. So all I need to do is return it, and it's asking for, I want the data point that goes with data index, like that. So that's all you have to do to create the data source. I'm going to stick that into a different file out of the way. And now I actually need to use it, which again is quite simple. The chart has a data source property. I'm going to make one of these new parabola data source things that I've just created and assign it to that data source property. And then finally, as with every other iOS thing, we need to add this view as a subview so that it actually renders. And then that should be everything we need to do. So this is at this point that I cross our fingers and run it up. It's built. Is it built? No. Yes, it has built. That's great. So now we just kind of wait for the iOS simulator to run up. That's an iPhone. Perfect. That's exactly what I was looking for. There's not that there was any worry that it might not happen.
There's a real sense of relief here.
Very much so. So there we are. That's exactly what we've got. And when we created that in Colin was going to time it. It's probably slightly over 5 minutes because I waffled, but
it was more like 7.
Yeah. If you were actually doing it, then you would only take 5 minutes. But there we go. So that's how simple it is to create one of those.
Excellent.
Okay.
Back to me.
Yeah. Okay.
Okay, well, thanks for that quick demonstration of getting started with ShinobiControls. So, as I said at the beginning, we want to show you a slightly more involved use of our charts and actually show a dashboard. A single chart certainly could not be called a dashboard. This is a project that myself and Sam have been working on for the past couple of weeks. It's on GitHub. You can see the URL there. We'll be sharing this. I think we'll probably be publishing it on our blog afterwards if you haven't got time to write it down. But what myself and Sam have created is a fairly simple dashboard app with lots of different charts and grids and things like that, showing data that we've taken from GitHub. So it's effectively a repository explorer. You can look at a particular repository and see some of the interesting statistics behind that repository. Before we dive into the code, and what we're going to do is we're going to look at the code, we're going to play around with it, make a few changes live, which will hopefully work, and show you some of the things we can do. But before we dive into it, I just want to give you a little bit of an overview of the application structure, just so you've got some familiarity with it before we get started. So it's separated into 3 separate layers. So at the bottom layer, we've got our data layer, our model layer. In the middle, we've got our controller, the ViewController, and at the top, we've got the view. The layer at the bottom makes use of a few components. So we're using REST Sharp and JSON.NET. So we're primarily using REST Sharp just to make it very easy for us to generate a C# API from a REST API. The iGitHub data provider is basically the API that we have constructed ourselves. So there we basically pass backwards and forwards C# types rather than JSON objects. The ViewController that sits in the middle doesn't really do much. It basically coordinates fetching the data from the data provider and then sending it onto the view. And as you can see in the view layer, here we're using the Shinobi components, again from the component store. We have a number of different views, which we'll show you in a bit. And each view is either a chart, a grid, or a gauge. And each one of those subclasses, the loading indicator view, which gives us a bit of extra functionality. It shows a wait indicator as the data is being loaded asynchronously. So hopefully that diagram will help you to understand the code which we're going to be showing you just now. Before we get into that, there are a few things you need to do. If you want to play with the code yourself, there are a few things you need to do to get up and running. Firstly, as I mentioned, all of these other dependencies are pulled directly from the component store, but for Shinobi Grids and Shinobi Charts, you need to input the license key, just as Sam showed you in the quick demonstration. But what we've done in this project is made it a little easier for you, so you don't have to paste the license key throughout the application. We've made a little appsecrets.json file which you can paste in your license key, and I'll just show you that now. So, if we open the GitHub dashboard, just so you know where you're looking, we've got a sample.json file which shows you the structure. If you want to get up and running, you copy that and rename it appsecrets.json and add in your license keys at the required location. So that's pretty easy to do. Finally, one other optional step, the GitHub APIs are rate limited, and they're fairly restrictive. It's only 100 requests, 50 something. It's a pretty low number. If you have a GitHub account, you can create an authentication token, and that will give you access to 5,000 requests an hour. So that's an optional step. But if you don't do that and it suddenly stops making requests, that's the change that you need to put in place. So again, it's over to Sam, who's going to first show you the dashboard up and running, and then he's going to attempt to add a whole new chart live.
Yes, wish me luck. So if I first of all, we'll just fire it up so that we can see what we're starting with, and then I'll run through what it is that we're going to do. So in theory, once this fires up, it'll be quite obvious what we're going to do. And here we go. So we've got 3 charts on here demonstrating various different bits and pieces. I'm not going to go into great detail about what they're doing because that's a tool of the GitHub API rather than what we're trying to do here. But we've got the ability that you can change repo, and then you can swipe across, and then we've got down here, we've got a grid with issues in it, and then a gauge that Colin briefly mentioned later. There is a big grey box down in this bottom right-hand corner, though, and some of you may have realised that that's what we're going to have a look at. So, let's go. So, what we're going to create in there is something called the punch card, straight from the kind of replicate this here. So this is a punch card. It's part of the GitHub, the graphing tools that you see down the side of your repos on GitHub. And basically what it shows you is what the kind of the life cycle of the project is almost. We've got the days of the week and the hours of the month, hours of the day across the bottom. And then each blob is representing how many commits you've had at a particular time. So what we want to do is create that, basically. So what we're going to do is we've got all of our different views are inside this views directory here. So they've got the code frequency view, for example. What we're going to do is create a new one of these. And we're just going to start with a C# empty class, and we're going to call it punch card view. Some kind of original naming. Now, we need to do a few bits and pieces to get this to behave nicely. So first of all, we'll do a bit of Xamarin magic so that it can punch card view. A bit of Xamarin magic so that it appears when we try and link it up, which is going to require an import. And then we're going to inherit from a loading indicator view, which has appeared there, which is the view that when you first load it up, then you get a little indicator in the middle. And all of our views need this indicator, so we just made a little subclass of UI view, which shows that and has a really easy API to turn it off. So, I mean, you can treat that as a UI view from what we're talking about here. But it implements this iData view interface with punch card data. Right, I shall now show you what that interface looks like. It's a very, very simple interface. All it's got on it is this render data method. All of our views implement this interface, and all that render data does is once we've got an asynchronous call to go and collect the data, and once that's arrived, then the callback tells the view, here you are, here's your data, go and render it. So that's all that's creating there. And then we want to replace this constructor with the Xamarin manage memory magic one. Cool. So what we also need to do so that it will compile nicely is implement this interface. So that's as I said, we've only got one method on that interface. For now, we'll just leave that. We're not actually going to call it yet. We'll come back to that later on. And then we just need to wire it up. So I know that it is in, so if I save that, we're going to put it on page 1 of our dashboard. So if I open up the nib that goes with that, and I want to go put it in the bottom right. So we set class, which because of that magic register thing has arrived, and then we need to create an outlet for it. So this is all perfectly standard stuff, which I believe will disappear when the Xamarin Designer appears, or will be made slightly less mystical when that arrives. Cool, so if I put those together, close that, and we can check that that's worked just by opening this constructed file here. Yes, it's got the punch card and it's doing all that kind of stuff. So now if we fire this up, we should see that we've actually successfully managed to link those bits and pieces together. Yes, we have. So you can't see anything at the moment, but you can tell we've now subclassed that and we've linked it nicely into the zip because we've got the loading indicator. So not very exciting, but at least we know we've not broken it yet. Right. So we're going to need, the main thing that in this is a chart. So we'll make a member variable, Shinobi chart, not charts, and it's going to be a bubble chart that we're going to, that will be our reference to the chart that we're going to manage. And then inside here, render data, when we get told to render it, then we're going to create the chart. Well, first of all, we're going to check, have we got a chart? Because if we haven't got one, then we need to create one. If we have got one, then we don't need to worry about it. For example, when you change repo in that drop-down list I showed you, then we don't want to create a new chart each time. We just want to tell it, here's some new data, go and render it for us, please. So there, we're creating it only on the first time. And then the other thing we've got here is this hide indicator. So that's the method on the superclass that I was talking about before. You'll notice that create chart is red because that's not a standard thing. That's the thing that we're going to create now. So we've got this. Let me just pull in these bits and pieces. So this license key provided JSON thing is the thing that goes and pulls the license key out of that JSON file, so that we don't have to keep copy pasting it in all over the place. Yeah, let's run through what this method does then. So this here is exactly the same as you saw with the parabola demo I went through. We're creating a chart with the new Shinobi chart method. This time we're not setting the axes because we're going to look at those in a second. Setting the license key and then making sure that it resizes nicely. Axes, we want to set some different things on here, so we're going to create them manually. We're going for a number axis in the x-axis, that's the hours of the day. So numbers, and we're setting a bit of padding so that our bubbles all fit nicely on the screen. And we're calling it hour, and then you just set the axis as an x-axis property on the chart, so we just set that. Same for the y-axis, only this time we've got a category axis because we've got days of the week, so they're categories, they're not a continuous property. Again, setting the day, and then same with all our things, we're just adding it as a subview. Right, grand. Now, in exactly the same way as we did before, we need a data source. So here, because we're not going to use it anywhere else, I'm going to make an inner class and call it punch card view data source. So it's going to inherit again from schart data source, which is the abstract class that I mentioned before. And we're going to use a fairly similar technique as we did before, where we will create a constructor that creates the data points, and then we'll reference them later on in the abstract methods. So the constructor that we're after, where are we? Is slightly different to the last one because we're now providing these punch card entries. These are just C# objects. There's nothing magic about them. They've got simple properties on them. I think this is a collection of objects that have like number of commits, day of week, and hour on them. It really is that simple. So we're gonna store a list of those again in a private variable. And then we provide these, and then we're going to make some data points out of them. We've got this nice method here called create data points and punch card entries, which we should probably create. which is exactly what we're doing here. So we've got this method. It returns a list of these, which is exactly what we want. It takes the entries. We've got a bit of link in here. Very simple stuff. All we're doing is we're only interested in the ones where we've actually got a number of commits. If we don't have commits, then we can't actually draw anything, so we throw that away. And then for each of those, we convert them using this create bubble data point from punch code entry. So we need one more method, which does exactly that. We get a bubble data point back, and we take punch code entry. So all this is doing, so before we used an S-chart data point, this is a subclass of that. It's a specialist one. We had X and Y values before. Now we have this area property as well. Because it's a bubble, we need to know how big it is. The X value, we're going to use the hour. The Y value is going to be the day name, and then the area is the number of commits multiplied by a magic factor, which is as magic as you need it to be. You play with your data and find out what it is. 50 seems to work quite nicely. And that's all we need to do. So those are the three methods that we'll create from when we create one of these objects. We now need to implement those same four abstract methods that we had before. Here they are. Number of series. Again, we're doing a nice simple one. So we can just have one series. The series this time, we want a S-chart bubble series. Bubble series. There we go. And then I need a new one of those. So we had a line series last time. This is a bubble series, just to demonstrate something slightly different. Number of data points. This is exactly the same as we had before. We want the count of the number of data points, and then the data point specifically. Well, we've got the data points, so we just need to get the one at data index, not data series index. There we go. And then that's our data source created. Again, really simple. Couple of minutes, and we've managed to put that together. And then, exactly as we did before, we need to create one of these data sources, so we should probably store it in a member variable. So we'll have a private, what was it called, a punch card view data source, and we'll call that data source. And then we need to create one of those. New punch card view data source, and we're going to pass it the data that we've been passed in. That's exactly what we requested here, render data punch card data. So we've chucked that into there. We need to update our data source on the bubble chart. Data source is equal to our data source, and then because we've changed the data source, we have to tell the chart, actually, can you go and redraw yourself, please? Because it can't. Because otherwise, if you're changing various different things, you don't want it to redraw all the time. So we just tell it, here's new data, go and redraw yourself. So this gets called every time, or will get called, we haven't done that there. We'll get called every time we get some new data, which seems perfectly reasonable. Grand. So that's everything that's associated with this specific view. We now need just to wire that up. So there's a couple of steps to do that. This is where it depends a little bit more on your app. First of all, we just need to expose the view that we're talking about here. So we'll call it punch card get this dot punch card. Yep, seems a bit short. Okay, because punch card is short.
I think we called it punch card view last time.
Oh, okay, right. So now we've got a property on our ViewController. That's the thing that's associated because we have multiple pages, so that's why we put that in there. And in our ViewController itself, we have a method here called fetch data for repo. This gets called the first time view did load. We fetch data with repo, and then this here is the tap handler, or the handler for when you select a different repo. It goes through and then it calls fetch data for repo with the new repo name. So we just need to add a bit at the bottom here, and it forms exactly the same pattern as these other ones we've got. We've got punch card entries. So this here is, I'm pointing at the screen, that's not very helpful. We've got this here is the method in the interface that I may have shown you, maybe I didn't. We have this data provider that Colin mentioned before with these different methods. So I've already got a method that, here it is, punch card entries. It takes the owner of the repo, the name of the repo, and then it has a callback for when it's got its data and it returns this punch card data. So that's the stuff that's all hidden inside this GitHub API layer. That's mainly done through the magic of REST chart. So we're going to call that, and we're going to pass it the owner. If I can type owner, we're going to pass it the repo, and then when we get our data back, we want to do some magic on the main thread, invoke on the main thread. This is fairly standard stuff. This is just because with updating the UI and iOS and indeed Android, that has to be done on the main UI. This dot punch. Oh no, this dot page one, so it's on page one. We made this punch card property, magic, and then we're calling that method that is defined on the iDataView interface. Render data, and we just pass it the data that we've been sent back. Really quite simple. There, so that now we've wired that up. And oh dear, what have I got wrong here? Ah, I need to return.
You miss out every time.
Every time, yeah. You wouldn't have to in Ruby. There we go. There we go, that's better. Oh, before I speak too soon. Come on, yes, it rendered. Yeah, I'm quite glad that so far, that's what is the only issue. So there, it's managed to render it. It looks a bit hideous at the moment, as the splodge, the big splodge. Let's look at how to fix that. Basically, the bubbles are scaled to a particular size, and at the moment that size is too big. So I'll show you this is just one of the many options that we can put into this. This is actually a property of the series. There are loads of properties on the series. I'm just going to have a look at one of them now. It's the aptly named Autoscaling biggest bubble diameter. There we go. That's a bit of a mouthful. And the number we need is 40. I do that every time as well.
Yeah.
I'm just going to tell you it's 40. You kind of play around with it. So this is this will rescale those bubbles so that they look a bit more approachable. And when that data loads, there we go. That's a perfect punch card view. That looks exactly the same. And this is showing, yeah, that's exactly what we expected to show. Cool.
The cool thing about that biggest bubble diameter is it doesn't depend. There's no dependency on your underlying data. That's the cool thing. So you don't actually have to work out what the maximum data point value is. Basically, it does the scaling for you, and that's
so no matter in our instance here, no matter whether you've got a repo that you're just working on yourself and you've got 3 or 4 commits, or you're working on one that's some massive distributed project with thousands of commits, that will,
it will just work.
It'll still scale it nicely. Cool. So the last thing from me is I just want to show you a little bit about the way that we can interact with charts. So at the moment, all of these charts are static. In fact, if we try and interact with them, what it actually does is pass us on to the next slide. But one of the key things about Shinobi charts, and because of the way that they're rendered in this in the GL layer, is that they're really nice to play with. You can plot tens of thousands of data points, and it's just you feel like you're playing with the data. So I want to show you. I can't really show you what it feels like to interact with it, but what I can show you is how easy it is to get that functionality out of it. So I want to pick on this chart down in this bottom right-hand corner, which happens to be called the code frequency view chart. So at the moment you can't do anything. So if I pull open the view that associates that, then I've made a handy little helper method which will enable the various different things. So the way that we specify this is each axis has these different ways in which you can interact. We've got the gesture stuff and the momentum stuff, panning and zooming. So I've created that because I don't want to type that out for each axis. We've got 2 axes, so I just want to enable the gesture on axis with the x-axis. Magic. That's not the x-axis, is it? I've put that in the y-axis section. And then up here, then I want to enable it on the x-axis. So with the kind of provision that you'll be able to see me working with the data now, trust me, go and download. Either we've got an app in the App Store called Shinobi Play, which demonstrates this really well, or get this and compile it and run it up on an iPad itself. It's really quite a pleasant thing to use. Let me just fire that up. Should be arriving. Just doing a bit of compilation. Here we go. So now, there we go. So now I've got, I can pan around it, and if you use the really handy pinch simulation gesture, then I can kind of move around and zoom in and that kind of thing. As I said, trust me, do this with your fingers. It's really intuitive. It's not at all intuitive with a mouse. But we don't design.
I can't even remember the key press you used to actually move that thing.
Okay, so I'll hand back to Colin.
Yeah. Okay. Well, what I'm going to be doing is having a bit of a play with the pie chart in the top left-hand corner. And I think one of the questions that's just popped up in the chat window is quite timely. Dominic's asked, are those pie charts a static image? So, well, we're actually going to play around with that pie chart and make some changes to it, so demonstrate that it's a Shinobi chart as well. So, one of the issues with this chart is I'd like to see labels on this data. I'd like to know how much JavaScript code there is within this particular repository. So at the moment, what we have is we've just turned off the labels. And I'll re-enable them and show you what happens. So what's going to happen here is it's going to render the labels, and they're going to show the value of the actual data point that each slice represents. And here you can see a big problem. The JavaScript, I think what that means is that there are 14 million characters of JavaScript code in that repo, possibly something like that, which is probably 14 million lines too many for anyone's liking. But either way, it's a great big number. And because of the size of the number, well, they're all getting clustered together and overlapping each other. What I prefer to see is a percentage. That's what pie charts are really designed for. So what we're going to do is go back to our data source and modify our data so that we are rendering percent rather than the actual underlying value. And here, again, because we are living in the C# world, we can do this with just a few lines of code. The poor Objective-C guys are going to have to write lots and lots of code to do this sort of thing. So the first thing we're doing is we're summing all of the data points, the value of all the data points together, and then we've replaced create data point with a slight modification that times by 100, then divides by the total. So this basically transforms it into a percentage. So if we run that, hopefully the data point labels will be a bit more readable. So as that fires up, let's take a look. Okay. That's much more readable. JavaScript, we now know, is around 90.6%. But we can tidy that up a little bit more. What we're going to do is, it's important to show your units. That's one of the things that I talked about right back at the beginning. So here, what we're going to do is add a label format string to the series. So this is available on pie charts, donut charts, line charts. Wherever you have a value on an axis, you can supply a formatting string. So what I've done is I've dropped it down so that we don't have any decimal places and added a percent symbol. So again, it's even more readable, 91% JavaScript. But we've still got this horrible mess at the top. So what this brings me on to is, so far we've just been talking about the data source. And just like the UI table view and other standard iOS controls, we have a data source for supplying the data, and then we have a delegate. And the delegate typically performs a couple of roles. The first one is it allows you to respond to events. So it allows you to respond to, in our case, things like selection events, pan, and that sort of thing. The other thing that the data delegate allows you to do is it allows you to make tweaks and modifications to the UI elements that we're generating when we render the chart. And that is what we're going to do here. So here's one I created earlier. So we're implementing we're subclassing schart delegate, and we're overriding the onAdding radial label method. So what happens here is every time the chart creates a label, it will invoke this method and allow us to make some modifications. So this is quite cool. You can do things like you can highlight certain labels on your axes, so you can make the top end red, for example. What we're doing here is quite simply hiding anything which is less than 4%. So the final thing we need to do when we create our chart is actually add this delegate. So hopefully, if I build and run, what that should do is that should hide some of the labels that are associated with the smaller slices and enable us to actually read the numbers. So there we have it. That's a fairly simple way of doing it. Other things you can do, if you wish, is you could change the size of the labels. You could make them shrink if the slice was smaller, or you could even push them out from their current location. I think we've got a blog post about that somewhere. Basically, the delegate is a great way to customize the rendering of these charts. Now, the final thing I'm going to do is show you some gratuitous animations. Users love gratuitous animations. Now, this might not necessarily be good data visualization, but believe me, people enjoy this. So what we've done here, I'll give you a quick demo first. Actually, I'll switch back there. What we've done here is we've set the protrusion on the selected style. Now, a series has two different styles associated with it. It has the regular style and the selected style. Both of them have the same properties, so the same type, but one of them is applied when the series is in the selected state. The protrusion here pushes a slice out from the center of the pie. So what that's telling you there is that when a pie piece is selected, to push it out. We can do other things. We could change the color, we could change the line thickness, all kinds of things. We've enabled animation on this series. We'll see that shortly. We've also enabled panning as well, which does something rather special for pie charts. So here, now as I select pieces, we get this nice little animation as they pull in and out. Actually, the entry animation, you might not be able to catch it because it doesn't render terribly well on a simulation. It'll probably render even more poorly over the webinar. But what happens is the pie chart expands from the center. All of these series have some quite funky looking animations. The gesture panning on a pie chart will allow you, on a line series will allow you to pan it. On a pie chart, it allows you to do something pretty funky. You can actually spin it around. And you might be thinking, why on earth would I want to do that? Believe me, put this in front of a user. Once they find that they can spin it around, they won't stop spinning it. So as I said, it may not necessarily be good data visualization, but it's certainly a bit of fun. So far, we've just been talking about the charts, the pie charts, bubble, line series. I want to talk a little bit about some of our other components, about the grid and the gauge. As we're already sort of 55 minutes in, we're not going to do any live coding on this. I'm just going to quickly give you a quick tour of some of the code we have in here already. As I mentioned at the beginning, this is all there on GitHub, so if you want to take a look, then feel free. So this is the data grid, and when you create a data grid, if you've previously been a .NET developer, as I have in the past, this kind of API should be familiar with you. It will be quite familiar to you if you've used things like the Windows Forms data grid view. So you create a data grid, you add a number of columns, and these columns have features associated with them. They can sort the data, you can set the column width, you can style, you can specify the type of cell that's going to be used to render that column, or you can specify the header cell, that sort of thing. Now with our data grid, there are a couple of different ways you can interact with it. You can supply a data source and a delegate as you do with the chart. But with the data grid, we've added something a little bit special. We've added this thing called the data grid data source helper. And that's a kind of helper class that sits in between your grid and your data. And what that means is you don't actually have to write a data source anymore. And it will also handle sorting for you, grouping for you, and all sorts of things like that. So what that means is, as you can see here, this file is really quite small, and the net result is that we get a grid where it's able to sort within the sections. We've got grouping, we can expand and collapse these groups, all with very little code. And you might have noticed that my face keeps appearing on the right-hand side. This is because we've chosen a repository that's close to my heart. It's a project that I initiated a little while back. That's why I'm all over it. The other thing I want to quickly show you is the gauge. As I mentioned, this is something that we just released on Friday. I'll show you the code for that as well. What that's doing is that's showing progress towards a milestone. So if you've ever run a project on GitHub, you can create a milestone and assign issues to it and basically track progress. So here we can see for the version 1.3 release, we have completed 4 out of 10 issues. So here, if we look at the milestone progress view, again, it follows exactly the same pattern that Sam's been talking about. So when we're supplied with the data, we use a nice bit of link to order it and take the last one. So we want the most recent milestone. And here's our gauge code. We've determined the total number of issues. We've created a gauge with that range. We've created this thing called qualitative ranges. That's the colored bands that you see. And here, it's a little arbitrary for this purpose. We've done some changes to the tick and the range styling. And actually, probably a better demonstration of the capabilities. Where is it? Oh, Chrome Canary. Okay. A better illustration of its capabilities is this is a project that I just put on GitHub now, actually, within ShinobiControls, which we're starting to put together a gallery of how you can style the gauges and some of the different styles that are possible. So that's probably a good place to have a look if you want to see that the gauge is really being tested out. And that pretty much brings us to the end. So that's our overview of the dashboards. And at that point, I'm going to be passing over to Mike, if you're still with us, Mike.
Yes, thanks, Colin. That was great. So as you saw, Sam showed the component store a little bit in his demo earlier with the parabola, and then the one after that. I'm just going to highlight a couple things briefly for folks that aren't familiar with the component store. You can flip the slide forward. The Xamarin Component Store includes a variety of different types of components in different categories, ranging from the great data visualization components, such as the Shinobi ones you've seen here today, to other user interface components, as well as there's even components for integrating with cloud services, to even themes, to name just a few types of things you'll find. So there's a wealth of things in there. And you can, it's all integrated within Xamarin Studio, as well as being integrated within Visual Studio. You saw Xamarin Studio today. It's fully supported within Visual Studio as well. So up on you can additionally view them on the web at components.xamarin.com. The screen you can see there is, when you go into a particular component, there's a detailed screen when you select it, and that has more information about the component, such as sample code for how to get started, as well as documentation for the component and other information such as API docs. And of course, the click to try it or buy it. If it's, some of the components are free and some are available for purchase. And of course, again, it's all integrated within Xamarin Studio and Visual Studio. So for easy, like one-click type access to install it within your project, like you've seen. So you can go to the next slide now. And the last thing I want to mention is for folks who are completely new to it, that if it's the first time you're you saw how easy it is, so it should be pretty much self-explanatory, but if it's the first time you're adding a component, we do have a walkthrough available up on our Developer Center. It shows you which will show you step by step how to do what Sam did earlier with the Shinobi control, just with a different one, but they all work kind of the same way. You just click one-click access and you sign into your account, and this will show you step by step how to include a component within within your Xamarin project. So that's the Xamarin Component Store, and hope you check it out.
Cool, thanks for that. So at this point, we've had some QA going on in the background, and there's just one or two I wouldn't mind reading out. Have we got the time for that, Rich, Mike? I'm guessing so. Okay.
Yeah, go for it.
Cool, thank you. There's a few I'd like to. I took you by surprise there. There's a few I'd like to pick out. A few people have been asking about, is this iOS only and Android? As I mentioned, our Android version of the chart is. We've got an early access program now where we've given it out to quite a few people. They're really enjoying it. And as I said, we expect the first release to be weeks away rather than months away, so we're very excited about that. Another thing that's popped up is iOS 7 support, and I definitely say we're all over that. We're downloading the developer previews as they arrive, as most other iOS developers are. We're making sure our components work, but not only that, we're going to make sure that our components match the look and feel. So we're going to make sure that our charts, grids, and so on look right within the new iOS 7, slightly more flat, more conservative look and feel.
Not at the exclusion of people that are still running iOS 6, so you will be able to, we're not entirely throwing away the stuff, so you can still make them look as they do now. So it's additional, it's not
exactly. Yeah, our components already have the concept of themes and styles, and we'll be using those ourselves to basically pre-roll styles that will look good on iOS 7 devices, which is cool. Another one that's popped out is someone said they've downloaded the project from GitHub, but they're missing Shinobi gauges. I'll be right on that. I'll update the README on GitHub. Basically, you've got to go to our website and download the gauges from there. I'll make a note to update the README file on that one. And I think the final one is, can those charts be animated from Dominic? Yeah, they certainly can. As I said, it might not be good data visualization practice, but it certainly puts a smile on your user's face. The pie charts will spin, slices will fly out as you select them, but all of the series as well have entry animations. There's quite a cool one we've created, which looks almost like the way that an old TV turns on. It pulls out from the middle and then expands. It's pretty cool, actually. So again, I'd encourage you to download the components and just play with them.
We haven't shown too much of that today, simply because the visual, the animation of things just don't work very well over a webinar. We do kind of suggest that you just pull it down, stick it on a device, and have a play with it, because I think it really does come across a hell of a lot better when you've got it in your hands.
Yeah, or the alternative is go to the App Store and download Shinobi Play. That's got some nice, really nice charts with lots of data points where you can explore the data. I think that's it for the questions I want to pick out there. If I hand over to you, Rich.
Yeah, thanks everybody for joining. The recording will be available, and I will email it out to everyone. So look for that. It'll also be available on our blog, either later today or tomorrow morning. And yeah, thanks again to Colin, Sam, and Mike and Stuart for answering questions. We appreciate this, and yeah, go to the component store, try out everything they said. We'll also have links in the emails and on the blog to all these resources. Thanks a lot, everyone, and have a good evening or day.
Thank you. Cheers.